Good. Clear to give it a record. Yeah. Seems that we are recording. Let's hope that it will not be laggy again. And yeah. So I'm trying to find for the shortest path that started as 0 and the t0, and obviously this path will, if the two closest point is A2 to B2, then this path will go from S0 to A2 along the shortest path to B2, and then to 2E0, and then I'm happy. That solves the problem for finding the nearest vertex from any point of A to any point of B. So that was one of the questions in homework 4, and I also asked to solve this question in the homework between segments, where first between a single vertical I gave you a set of vertical segments and asked to find a path that goes from the leftmost to the rightmost of this vertex, or from one specific point of a segment to another point of a segment. And in the midterm, I just combined these two questions, and I painted some segments, called them capital A, painted some segment, called them capital B, and looked for the shortest path that avoids all the segments. Look for the shortest path that avoids all the segments, and go from a point of a segment of capital A, let's say A1, to a segment of capital B, say B1. So the same trick would have worked very nicely. So that covers this question of the midterm. I also gave you the version of the midterm where I was insisting on segments that are only vertical. The source was a single point. The target was a single point, exactly the same version that you had in homework 4. But I want a solution that runs in order n square, where n square is essentially the number of edges in the graph. That is, I connect every endpoint of a segment to every other endpoint of a segment, provided that they see each other. This gives me at most n square such edges of the graph, because there are n segments, and between each segment has two endpoints, so it's order n square. And now I want you to run Dijkstra. And there is several solutions, and they are all legit. One is saying I can use Dijkstra, but instead of using normal binary heaps, I will use Fibonacci heaps. Fibonacci heaps allows you to solve the whole problem in times n squared plus n log n. Fibonacci heaps is a data structure that does everything that binary heaps are doing. It allows to change the weight, it allows to delete the minimum. However, decreasing the weight of a vertex will cost order 1 time, amortized order 1 time, if it makes any sense. And so the time to relax for the relax operation is constant. It's a solution that is absolutely correct. I did not teach it, and Fibonacci heaps are not commonly used in practice. In practice, they are a bit slow. So, but it is a correct solution, and if you are using sources of sources like check.com or Overstack or other places that you look for solution for exactly my questions, you'll find students historically solving this question using Fibonacci heaps, and it's correct. A solution that I spent a lot of time on this course on, and hoped that you'll use, is to say, hey, if it's only segments and they are all vertical, I will never have a case that the shortest path, will never have a case that the shortest path have to go to the left, then go to the right, and then go to the left again. because if I have to go to the left and then to the right again, I can shortcut just over here and make it a monotonic path. And if it's monotonic path, all my edges are going only to the left, then they have a direction. Going to the left meaning that doesn't mean necessarily going horizontally to the left. It just means that the starting point of every edge is to the left of the ending point of the very same edge. Again, the starting point has a smaller x value than the ending point. And now I direct all these edges. Obviously it's becoming a graph. It's becoming a directed acyclic graph, DAG, because it's directed, and obviously I cannot have a cycle, because a cycle means that I have to start from a point, go to the right, go to the right, go to the right, and go to the same point that I started from. Makes sense. So it's obviously a DAG, and in a DAG I can find many shortest paths a problem, including the shortest one, including the longest one, including many others, in a DAG by one path of all the edges, similar to BFS, provided that you have topological order. So you can use Kuhn to give you the topological order. Just realize that if I sort the segments from left to right, it is a good topological order, so you don't have to use Kuhn. Either way, after Kuhn gave the topological order of the vertices, and then after that, you just need one pass of Dijkstra or one pass of Bellman-Ford. Now, they actually, when you are using it DAG, it becomes exactly the same algorithm. And then the running time of both of Bellman-Ford on a DAG is order V plus E. Number of edges plus number of vertices. E in this case is at most n squared, possibly less. V is order n, 2n to be precise. So that's the solution that I was after. So that takes care of big chunk of the midterm. Any other questions about homework 4 or about the midterm? They had a lot of overlap between them. Good. So let's continue with finding the finding the LCS, the topics that we discussed just before the midterm. LCS, remind you very quickly, what is the longest sequence of segments that you can fit between a sequence X to a sequence Y. You have a set of characters on X, you have a set of characters on Y. You want to delete some characters from X, so you're left with a sub-sequence of X. You're not changing the order of any two sequences of X. You're not changing the order of any two sequences of Y, but once they are left, there is a one-to-one matching between them. And you're asking, what is the longest such sequence? And just before the end, we had before the midterm, we discovered that if we are looking at the where was a nice slide, that if the last character of X fits the last characters of Y, then the optimum length of the LCS of the whole sequence of X and the whole sequence of Y, if they fit each other, is just the maximum matching that I can find when I drop the last vertex. We had a notation for it that was Cm-1 n-1, the length of everything yellow besides the last one. N-1 was a prefix of everything in yellow dropping the last characters, and add to it 1 because you do match the last two characters. You cannot go wrong by adding these two characters. which now, and the other case that we had was that the last two characters don't match each other. The last characters of x is different than the last characters of y, and in this case the optimum matching was just the maximum of the two following values. They match everything in x, including the last characters, match all the characters in x to all the characters of y, excluding without the last character. So it's C of everything in x, denoted by m. Everything in y, excluding the last one, is n minus 1. We are not trying to match the last characters. And at the same time, we are also looking at the symmetric case of match everything in y to everything in x, however, delete the last characters of x before it, and the length of this LCS is denoted by C of m minus 1, comma, m minus 1, the last is a little, comma, n. And it's do repeat these, the lectures from this part. And after a lot of discussion, we noticed that we can run this algorithm in a very non-efficient way. If we don't memorize anything, then the running time might be exponential. However, if we'll just memorize in a table what are these CMN for every possible m and n, or every possible I and j, then we are getting to really, really simple algorithm, which just after initialization check for every possible I and every possible j. If xi equals to yj, the ith character and jth character, then cij is just ci minus 1, j minus 1 plus 1, add one character. Otherwise, drop the last characters of x, drop the last characters of y, and check which one gives you better way. That is, we're going to have some big table. We are going to have some big table. In this table, we have cells, and I'm just concentrating on one particular cell, the red cell over here, and I'm asking what should be the value of this cell. Well, I need to know what is a I and j that fit this red cell, and if xi equals yj, then the value that I'll write in this cell will be the value that is written in the diagonal cell plus 1. That is, if in the diagonal above cell the number is, I was able to match 18 characters in the I minus 1, j minus 1 case, there is already 18 characters that are matched, then the number that I'll write in the red cell will be 18 plus 1, making it 19. That's if xi equals yj. And if xi is different than yj, then the value that I'll write over here will be, look at the cell just above you, the I minus 1j, look at the cell to your left, the ij minus 1, look at the number written here, say 18 as well, look at the number written here, say 16, take the maximum of these two numbers, that's what you're writing over here, 18 in this case. So that was the overall algorithm. Please, the running time and the space complexity. What is a space complexity? I need an array of size m times n, this two-dimensional array that is C over here. So we went in class over how we are filling this table. We first fill the leftmost column, then fill the topmost column, all with zeros. That's the initialization. And now, for every I and j, we are just applying the rule that obtained over here. And note, and it's important that when I'm in the ij case, when I want to write a value to this cell, then the value of this cell, and this cell are already computed, already memorized. I don't have to recompute them again. And once I know what is the value in the bottom right corner, once I know what is the value of the bottom right corner, that is a C of mn, that's the length of the optimum LCS, I can find a way, find a path that leads to the 0, 0 that is always written at the top left corner. Basically, by just asking which of the two rules did I apply for every such path. So typical questions that I ask in finals or homeworks is, how can I know if there is more than one LCS? Given x and y, how do I know if there is a single LCS or are there more than a single LCS? That is, the LCS, are there two matchings, both with the same length, but fitting both different characters? And the answer is just check if there is only one path from the bottom right corner to the top left. Is there only one path that relates to the matching, or can you find two different paths? And they let you figure out the details of how from this table I can figure out, I can generate an algorithm that can find different matchings all the time, all that are optimal. The algorithm itself, as I said, at each iteration, you start from the last character and you find your way backward. Completely analogous to what we did in Dijkstra and Bellman-Ford, where we first find the path from the source to the destination. We first find what is the cost of the path from S to T, and then we could use a pi value, or if you're willing to spend a bit more time, then we don't need the pi value, but we'll find who gave, I know what is d of t, the length of the shortest path to t, which vertex gave t its current value. Let's call it v of k, who gave vk its value. Here is d of vk, sorry, d of vk, which vertex gave d of vk, gave vk its current value. That's just the proceeding vertex along the shortest path, and I can find my way all the way back to t. You had homework questions about it. Okay, let's start speaking about, we have an animation of how do I find a possible LCS. Over here, which you know, the diagonal are exactly when a character of x fits a character of y. The diagonal here comes because I match the a to the a. And this is not the only LCS in this example. You can also, similar to the, you can also, when you fill the table, when you run the original LCS algorithm, leave for every vertex a pi value, similar to Dijkstra. Here I'll just denote it by an arrow. This arrow is either diagonal or going upward or going to the left. Just which of the three vertices gave this vertex its value. And you can think about it as finding a weighted. The LCS is essentially find the shortest path in this graph whose vertices are just the cell of the matrix. It will help you in some homework, so I'll say it again. You can think about the whole LCS problem as a problem of finding a shortest path in a graph. Which graph? Its vertices are the cell of this matrix, and every cell is connected to its three neighboring cells, one to the left, one above, one diagonally above and one diagonally and one above. Make it into a graph and find the shortest path or the longest path in this graph. Okay, I want to talk about a different problem called the edit distance. Different but very much related to the LCS problem. Practically, you'll probably see it in many more examples, and it's called the edit distance. So what is the edit distance between two strings, x and y? I want to say that so the edit distance is defined as, look at a sequence of operations that takes x, and using these operations, you can make modifications to x, and at some point, you hope that x will become y. And you're asking, out of all these sequence of operations, what is the cheapest one? I want to make as little operations as possible and ask what will take x and make it y. So far it looks very abstract. What do I mean? So quick example. So this is a word that I just typed. I just typed the word hello. And my editor has an auto-spelling running, and it looks at the dictionary with all the English words. I only wrote 3. It will look at all the English words and will ask, is this a word in the dictionary? As far as I know, this is not a word in the dictionary. No, it is not a legit word in the dictionary. Okay, so what is a word that I probably meant to type if that's a word that I actually did type? So it is possible that I meant hey, but I typed hello. Well, it's possible. Well, they both start with A, there is E, but you see that there is many more characters that I typed over here, which means that if that's what I had in mind to type, hey, and that's the word that I typed, then it involves a lot of typing mistakes that I performed. Means that I meant to type Y, instead I typed L, then I typed another additional L, O, and W. I made about 5 typing errors to get if that's what I had in mind, and this is what I typed. So to go from hey to hello this way will take about 5 error mistakes. What about cat? Well, it will mean that I had a mistake of this letter, I had a mistake in this one, add a few more, it will be about 8 errors. While if I think about hello written in this way, then the only typing mistake that I did was that I added this W at the end, and this just means the cost is only 1 error. Make sense? So out of these 3 words, probably the one that is the closest to what I actually typed is the word hello. So this iSpell, if it knows what it's doing, will correct the hello with the W to the hello without the W. Again, how does it know this one? Because I compute what is the minimum number of typing mistakes that I made with respect to each one of the dictionary words that brings me to this hello. And the most likely one is the closest one. If you like philosophy, it's a bit similar to Occam razors. The Occam razor will tell you it's the simplest explanation to this phenomena of that's what you got versus that's what you meant to get. And if I want to become a bit more fancy about it, not only asking about what is the number of error mistakes that I'll make, but I'll give some errors different rates than other errors. For example, if I made a confusion between A and S, A and S, maybe they are more likely that they are, maybe the cost of this error is more likely, more acceptable because A and S are next to each other on the keyboard. Look on your keyboard, A and S are next to each other, so it's more likely typing mistake versus A and G. So I can give different weights to each such error, or can ask about combination of errors that tends to be together. It doesn't have to be one-to-one. Let's start from enough explanation, enough motivation. Let's say that behind every speech recognition program, behind every voice recognition, every error correction, there is an algorithm that is basically using edit distance or a fancier version of edit distance that asks what is the most likely combination that explains this error. What the speech recognition understood is not exactly an English word. What is the English word that I most likely, that has a least penalty that I probably meant to say. Okay, quick definition. I'll say that in this version of the edit distance, every error has a cost. An error can be expressed as I need to insert a character and it costs me 1. I need to delete a character and it also costs 1. Or I need to replace one character by another character which also costs 1. And I'm asking, what is the edit distance, ED, that takes me from AABA into AABA? And the answer is, if that's where I started from and I end in exactly the same word, then nothing needs to be replaced, deleted, or inserted, so the distance is 0, obviously. Let's take another example. Which operations will take you from AAA into AABA? How can I get from AAA to AABA? Well, you can have different explanation that will do it. Maybe I want to replace this character by A, replace this character by B, insert another A, and you'll get this character. So you can get it by one replacement and one insert. 2 operation. So that's one option, but you can get to the same operation by just taking, as we started, from A, and just insert B in between. Insert B, so just one operation, hence the edit distance from AAA to AABA. You always pick the cheapest sequence of operation. The error is 1. Possibly the error you can get from here to here by just inserting one character. It's not the only explanation, but that's the cheapest one at least. Next, what about AAA into ABAA? Again, you can perform deletion, insertion, deletion, or various other operations. The cheapest one is just take the second A, this A, and replace this A by a B, so the distance is 1. What is the distance from BAAA to an empty sequence? Not very hard. I can just take this sequence and perform 4 deletions. If I perform 4 deletions, each one costs $1, so I spent $4 on the whole operation. What about BAAA? what's the distance to B. That's a case where you can get to it in different ways. Right. Presumably, I can replace this character and replace this character. So two replacements. I can delete this. I can delete. Sorry. Alternatively, I can delete this B and insert 1A at the, no, I can delete this B and insert 1B at the beginning, one deletion and one insertion, another way. You can find a few different processes, but all of them requires two operations, so the distance from this to this is 2. Cool with everybody? Okay. And actually, that's edit distance is one of the cases where I think that the explanation becomes much simpler if I'll give different weights to each operation. So assume that I tell you about three constants at the moment. One will be the cost of insert one single characters into X, and that will be the insert cost. It's some the value that the user told you. That it has a cost which might be different than the cost of a single deletion from X. Might be the same, might be different, and the cost of one replacement of one character into a different character. By the way, when you are matching DNA or RNA, another very popular cases where edit distance is heavily used, then you are thinking about all these operations as mutations and ask, given one target DNA and several other proteins or several other DNAs, out of all these animals, which one is the nearest one, has a minimum number of mutations that takes you from this DNA into this DNA. And you can speak about mutation only of the types of insert, delete, or change one bases, or you can think about gap edit distance, which is very popular, that says, hey, there is a whole piece of code that just vanished, and this whole piece of code, I can delete all of it because of biochemistry. I can delete all of it in just one single operation, so the cost of deleting many characters is much smaller than the cost of deleting many consecutive characters is much cheaper than the cost of deleting the same number of characters but not next to each other. It's possible that the gap edit distance. Very, very popular, and Professor Casasioglu is a world expert about everything that has to do with matching two or much harder, multiple DNAs to sequences to each other based on all these operations using edit distance. I was exposed to edit distance when I worked in IBM in part. It was related to speech recognition, and we were using the error matrix to denote similarities between phoneme. How likely it is that one phoneme, like R, A, O, part of the speech that was recognized by a different one. So the error is a function of, might be different depending on what is a character that is inserted or deleted or replaced. But again, it's very, very popular, and you can definitely convert using log likelihood. If it sounds familiar, you can use the edit distance to answer question of what is the most likely, that is the one that has the highest probability of the error that you said or written or used as a gestures, given that there is an input that I just recorded. So again, you cannot overestimate how important edit distance is. Another important part of edit distance is when you have two files, file 1 and file 2, and you want to find the diff of this file. Which changes of this file 1 do I need to do to get into file 2? What is the smallest changes that one can do to create from file 1 and end in file 2? Why is this so important? Because when do you use it? When you are you guys familiar with incremental backup? What does it mean? What is incremental backup? So I'm creating a backup of my hard drive at day 0. I mean, on Monday, I stored file 1. The file, the whole file, the file that it was given on day 1. Okay. Now, on Tuesday, I have file 2 because I worked on file 1, and file 1, after a few edits, got to be file 2. And I want to be able to reconstruct file 2 if somebody will delete it, if my hard drive will crash. But what will I want to be able to access file 1 if to get to earlier version of the files, as storing multi-version of the file. I want to be able to get to it for either Monday, to reconstruct what was a version in Monday or Tuesday or Wednesday, and which will give me file 3. And at each part, what will I store as the difference is just what are the changes between file 1 and file 2. That's the only thing that I'll store, but I need to reconstruct what are these changes, and edit distance exactly comes to answer. Here are the changes that happens to the file in the as compact, as compressed as possible. Similarly, what you'll store from Tuesday to Wednesday is what changes happen in the file only for these changes. And now if you have these changes, the deltas of the file, delta 1, 2, 3, 4, I can reconstruct each one of the versions without having to store the whole file from scratch at each operation. I just need to store what are the deltas at each time. But to know what is the most compact delta, I will use the edit distance algorithm. Extremely popular. Okay, so in this very simplistic version, there are only 3 constants: insert, delete, and replaced cost of a single character at each problem, and which problem are we going to answer. Given 2 strings, x and y, we want to we define the edit distance, ed, between x and y as the cheapest sequence of operation that starts of x and ends at y. That will take file 1 and will generate file 2. And the cheapest here is by insert cost some number of dollars, insert of a single character, delete a character cost some number of dollars, replace the constant cost some number of characters. And that's a problem that we want to solve. Find this cheapest sequence, and of course store this sequence. As usual, we first compute the cost, and once we know what is the cost, we can reconstruct the actual sequence. Okay, how am I going to compute it? I'll use the very same notation that we used for the LCS. So x from 1 dot I, remember, x from 1 dot I is a prefix of the first I characters of the sequence x. Y from 1 dot j is a prefix the first j characters of a y. I'm looking at the cost of the added distance. The number is what happened when I added the individual cost from this prefix into this prefix, and I'll call this number Cij. So Cij is a prefix, is a cost of the LCS that starts at the first I characters of x and ends at the first j characters of y. And this is defined for every I and j. I'm sure that it's hard to follow it if you see it the first time. You have to compare this definition of Cij to the similar definition of Cij that we saw for the LCS. So they are quite related, and it's more or less very similar notation. What does the user wants to know? The user wants to know what is the cost, what's the added distance between Cm. What is Cm? It's corresponds to the prefix of all the characters of x and all the n characters of y. Prefix that contains the whole file of x, the whole file of y, the whole strings. We had a similar theorem in the case of the LCS. Let's see what is a structural sequence in the case of the y. So big difference between LCS and added distance. LCS, longest common subsequence, tries to maximize the matching. Added distance tries to minimize the distance. Maximize versus minimize. Here I'm trying to pay as little as possible. Here I'm trying to match as many as possible. So let's say that I'm looking at x from 1 all the way up to I minus 1. The last character is I minus 1. I'm looking at y all the way from 1 up to j minus 1. Let's say that's everything that I know about so far. That's everything that I know about so far. That's the case of the I minus 1, j minus 1. And then suddenly the oracle told me, hey, there is a ith character over here, and it happens to be g. There is a one character here that happens to be the same g. It's the same character, so that's not in the j direction. That's not in over here. It's over here. It's a j characters. It's a j characters over here. Here is g. Here is g. The very same letter. And by the way, you have found already, you computed the cost, the optimal cost that matches everything here in the first I minus characters of x to the first j minus 1 characters of y. This is a optimum matching. Switch colors. This in blue, I'll say that's the optimum matching, or the minimum penalty. So the minimum penalty is a minimum operation that starts at x from 1 dot I minus 1 and takes you into that's you already computed. What is the optimum matching of the blue part? And now I added one characters of x, the ith characters of x at the end of x, the jth characters at the end of y. And I also tell you that this is the optimum character, that it is the very same character. Similar to the case of the LCS, I'm in the case that xi equals ij. It is the very same character. You already decided about a sequence of insertion deletion operations that takes the red portion to the red portion. You're already willing to pay for it. how much more will it cost you to match everything here to everything here, given that it's the last characters? The same, they all have the same last character. Do I need to do anything to this G over here? I don't need to change it. It's right. I don't need to change it. It's the very same character. Don't delete it, don't replace it, don't add it. Whatever you need to do that takes you from here to here, you don't need to pay anything more because of this G at the end. Make sense? So in this case, xc, in this case, xi equals yj. So cij is just ci minus 1, j minus 1. Don't need to add any extra cost. But that happens only if this character is exactly the same character over here. Let's see a quick example. X equal ABC, Y equal ABC, and I want to know what is C of 3, 3. C of 3, 3, 3. Let's give a name, ABC, A, 1, 2, 3. What is X3? X3 is C. Y3 is C as well, it's the same character. So C of 3, 3 is just using this theorem. C of 3, 3 is just C of 2, 2, and you don't need to pay any extra penalty. Remember, the cheapest you are getting, the better for you. It's just C of 2, 2. What is C of 2, 2? Recursively, what is X of 2? X at characters 2 is B. Y at character 2 is B as well. So this is just C of I minus 1, J minus 1. I don't need to pay to make the B into a B. No penalty. Which is just C of 1, 1, which is C of 1 minus 1, 1 minus 1, C of 0, 0, and to match an empty sequence into an empty sequence cost a 0. So that was the easy part. What is the else if xi and yj are not the same? And I feel the need to remind everybody what is the two notation. Xi, if x is a, b, c, then x2 is b, while x of 1 dot dot 2 is a prefix of the first two characters of x, is a string ab. Hopefully everybody's cool with this, with the notation of x of 1, 2. So what is the else? Else is xi is different than ij. That is given our previous notion. Here is x from 1 all the way to I minus 1, and in the ith cell there is g as before, and at y 1 up to j minus 1, and there is a k over here at the j's place, and j is different than k. But I do want to, but I'm describing a version of operations that will take the whole sequence over here and will make it the whole sequence over here. So how can I make the j into a k? There are three options. Option 1 is take everything in red, x from 1 up to I minus 1. Since it's everything in red, then the j over here needs to be in blue. Take everything in red over here and find the optimum matching from the red over here to the red over here, which is denoted by the cost of ci minus 1, j minus 1. And how can I convert the j into the k? Well, I have the cost of replacing a single character. So Cij will be given by Ci minus 1, j minus 1, how much it costs to match this to this, plus the cost of converging a j into a k, which is a constant given to me as a replacement cost. That's one option. Another option is match everything in the match everything in here into everything in here, including the k. And what happened to this g over here? Well, this g will have to be deleted. So I'm matching everything from character 1 all the way up to I minus 1, all the way up to I minus 1, and the g has to be vanished. How do I vanish? But if it's vanished, it's fine, except that you need to pay for it. So it's a cost of matching the first I minus 1 characters of x into all the characters of y, including the k, and get rid of the g over here. So if you are getting rid of it, you have to pay for its vanishing, for the deletion. So it's ci, whatever you paid so far, which is ci minus 1j, plus the deletion cost. That's the second option. And there is one more option, which is to take everything, including the j. The j is back to life at index j is back to life at index I, and I'll match and I will match everything, including the j over here, into everything not including the k. So what happened with the k over here? It means that to get back to the k, I will have to insert the k. To get back to the k over here, to get back to the k, I will have to pay for insertion of one new character. So that c of I, everything in the beginning to only the first j minus 1 characters of y, plus insert one more character. So you had these three options: replace the j by the k, or delete the j, or insert the k. And each one possibly gave you a different cost. Which of the three operations should I do? Very simple, the cheapest one. Out of all these three options, pick the ones that cost you the least. As simple as this. So I'll Cij, in the case that xi is different than yj, then Cij is just the minimum of these three numbers. And that's the whole theory behind it. Let's see what it makes the algorithm into. So this time I'm not going to go through the whole exercise of first giving you a recursive and very exponential time algorithm into it. I'll go to jump. See, because of the similarity to the edit distance, to the LCS, I'll just jump to the code directly. So the algorithm, after computing the solution to a sub-problem, we store the solution in a table. And if we need this value from the table, we'll just go to the right cell of the table and pull it up. And here is the algorithm. The initialization is a bit more interesting. For I equal goes to from 0 to m, ci, comma 0 equals, let's think about it. Let's take x equal abc, y equals ABC, the same file as well. But I'm asking, what is the cost of C of 2, 0? What is C of 2, 0? Let's understand what it's an abbreviation of something, it's a shortened of something, of shortening what? Take the prefix of x1 dot dot 2, which is a b, and ask what is the cheapest way to make it y from 1 dot dot 0. C of 2, 0 is take the first two characters of the prefix of first two characters of x and convert them to a prefix of 0 characters of y. What is y from 1 to 2, 0? It's an empty sequence. What is the cheapest way to take a b and make it into an empty sequence? Well, I'll have to, one option is to delete the a and to delete the b, and probably that's the cheapest option. So the cost will be 2 times the delete cost. 2 times the delete cost in the case of 2, and if I replace the 2 by an I character, 1 or 2 or 3, then instead of 2, I'll have to replace it by an I. So for I, in the initialization of the table, for I goes from 0 to m, C of I comma 0 is I times the delete cost. But again, we have the same table as before, putting x over here, putting y over here, similar to the LCS, and now we are initializing the left column. But instead of writing 0, we are writing I times the delete cost. And similarly, how can I get from an empty cell what is in the very same example? What is C of 0, 2? 0, 2, then start with an empty cell, the prefix of the first 0 characters of x, and converge it into 2 characters of y, namely AB. How can I get from empty into sequence of 2 characters? Perform 2 insertions. So for j equals 0 to n, C of 0, comma j, the prefix of the first j characters, just pay j times the cost of inserting 1 character. That is, j in our case will be 0, 1. Will be 0, 1, 2, 3. So let's take the example of x equals a b, y equal a g b. So here is x, here is y, a g b, and let's assume that the cost of every operation is 1. Keep it simple at the moment. Then what happens here? C00 is 0. Inserting 1 character cost 1, 2, 3. Deleting 1 character is 1 and 2. So this is how I initialized my table. And now, just as before, for I goes from 1 to m, for j equals 1 to n, if xi equal yj, then xi if xi equal yj, then cij is just ci minus 1, j minus 1, no need to change anything. Otherwise, cij is a minimum of, when we are thinking about a cell, at this point, when we are thinking about, in the second case, when we are filling out a cell, we are looking at the three neighboring cells, this cell just above, the cell just to the left, and the cell just diagonally. And out of these three cells, we are looking at the numbers, adding to each one the corresponding cost, but only these three numbers are relevant for us, and this will be what determines the value over here. Let's see how it works. In our example, so for I goes from 1 to n, for g equal 1 to n, is, let's think about the case of I equal 1, j equal 1. I'm in this cell. What do I write in this cell? Help. We are in the case that I equal 1, y equal 1. It's the same character. So Cij is Ci minus 1, j minus 1 plus no penalty. 0. The A fits the A. Okay. And does the A fit the G? No. So what do I write in the A? What should I write in the purple cell? In the purple cell, I will write I have three options. I need to look at the cell to my left, the cell above, diagonally, the cell to my right, and it will be the minimum of the cost of one deletion, or one replacement, which will be the diagonal, or the cost of one insertion. So it will be either 2 plus 1 insertion, making it 3, or 1 plus 1 insertion, or the cost of just a single, the cost of 1 plus 1 replacement, or the cost of 0 plus 1 replacement, cost of just one insertion. Just insert the G over here, insert the G, so takes the cell to your left, which is 0, and add 1 insertion, making it 1. Okay, and the cost of matching the A into the AGB, the cost over here will be again the optimum of taking the 2 plus 1 replacement, or the 1 plus 1 insertion, or the 3 plus 1 deletion. Either way, it will be 2, because I can get it from here. Now, from the B, 2, it will be also 2 over here. The interesting case will be what will happen when I'll get to, it will be 2 over here, trust me. What happened when I get to the last cell? I'm asking, is the B matches the B over here? Yes, I do. The B matches the B over here. So you will, in this case, Cij, since they match, you'll use a rule that Cij is just Ci minus 1, j minus 1. Yeah. Okay, thanks for participating, Michel. It's so good. So we have the 1 over here, at the B to the B. So Cij just Ci minus 1, j minus 1, no penalty, making it 1 as well. But so makes sense to go from AB into AGB, cost me 1 insertion. And yeah, time and space, again, the time of keeping this array all together. Now, a question that will appear in all homeworks, in all finals, will be: can you delete? Can you make the running time, the can you decrease the running time? And to decrease the running time is in general hard. You can decrease the running time. Why do we care about it, decreasing the running time? Because M and N might be very, very large DNA sequences, might be very large files. So computing the edit distance now, if it runs in n square time, m times n square time, it could be really, really slow. Can I decrease the running time? Yes, but it's a bit more complicated. Can I decrease the space? Because as I mentioned many times in this course, it's very common that what kills the performance of your algorithm is that you cannot squeeze everything into the main memory. So can you actually decrease the space? And the answer is depending what exactly do you want. If your problem is compute just I have a query sequence, query DNA sequence, and I have a few other sequences of library, and I just want to know what is the cost of the edit distance between the input and each one of the ones in the library. And I just need the number because I want to know what is the nearest one, which is a common case. And let's think about, and in this case I want to care about the cost of the edit distance more than the matching itself, at least, to start with. Can I decrease the space required for it? Well, it looks like I need a whole array of size m by n, but let's see how do I fill this array. The same for the LCS. When I filled the first row, and that was in the initialization. Then I used the first row in order to write values into the second row. When I'm done writing values into the second row, I can use values from the second row to write values into the third row, and so on. So when I'm filling up in general, while you are writing when I'm writing on the ith row, I'm right into the ith row. Which rows am I reading from? And you think about it and you realize that you only need the I minus 1 row. You read value from this row and write new values into this row. But only when you are done working on the ith row, only at this point you are switching to work on the I plus 1 row. You're working on the I plus 1 only when you're done filling up the ith row. What does it mean? That at this moment you don't need the I minus 1 row, so you can write into it. So how can I save some space? I can just store 2 rows and do the following type of choreography. I will read from this one, I will write into this one. When this is fully written, I don't need this one anymore, so I can start writing into this one. The array that I used as a first row is now becoming the third row. And when I'm done writing into the third row, I'll take the second row and it's becoming the fourth one. So in this way, I just need 2 rows in memory. So it is enough to store only 2 rows at each moment. But is this true or is this false? Well, it's true if you only want to know at the end what's written at the lowermost right corner, and because that's a distance. So it will help you compute the distance. But why do I need all the history of all the previous row? Well, I'll need them if I do want to find what is a path that takes me back to the first row, because I actually need to compute what is a matching, what is a LCS, what is a diff. So the answer is that if you want to know what is a whole matching, the whole diff, what character matches which character in the other, or which components are the same, which do you need to replace, then you need m times n space. If you only want to know what is the cost of the edit distance, then you can do it with only 2 rows, which is order m only, 2 times m or 2 times n, whichever is smaller. And we are moving into the third algorithm in this section, which is a subsection of dynamic programming. So we talked about LCS. And we talked about edit distance. There are 2 neighbors, two relative to each other in the same family. And now we are going to talk about similarities between geometric creatures, to be precise. We want to talk about similarities between polygonal paths in a geometric setting. And they are going to be very similar, the same philosophies that we used for the edit distance and the LCS. So let me define first what is a polygonal path. So when I'll give you a polygonal path, it's not a polygon. It's not a polygon. Polygon is a shape that contains some area inside it. Instead, it's a list of vertices. P1 is a vertex, P2 is a vertex, P3 is a vertex, points on the plane or in space. And I'll think about it as between what makes it a polygonal path is that I'll understand these vertices as between P1 and P2, they are connected by a straight line segment. A straight line segment that goes from P1 and P2. And once I get to P2, I'll continue into P3 via a straight line segments into P4, into P5, all the way up to Pn. That's what forms a polygonal path. So it could be part of the scheme of this polygon if I'll drop the same path. And this polygonal path might be self-intersect. Possibly it is self-intersect. The last vertex might be the first one or not. I don't care. It's all polygonal path out there. Okay. So now when we are talking about when we know what is polygonal path, I can ask, given one polygonal path, capital P, whose vertices is P1, P2, P3, all the way up to Pn, and here is another polygonal path, Q, given whose vertices are Q1, Q2, dot, 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 Qn. I want to find a way to ask, are they similar to each other? Are these 2 polygonal paths similar to each other? Can they represent the trajectory of a car that moves along some road? And these are the GPS points that I measured along different points of this road. Is this the same road? The GPS has some error. The points, the vertices doesn't have to be exactly the same, but it could be the same trajectory. It could be a trajectory of an ant that was walking and looking for a path, and I'm looking for an explanation to the behavior of the ant, or migration of birds. Or it could be validating if my signature, the signature on my check or my credit card, is the same signature that I used when I deposited when I told my bank that that's a new signature, right? To check, to compare it between images. So there are many reasons to compare path into other path. It could be, and it has been used intensively as a way to predict behavior of stocks. Is a behavior of one stock similar to behavior of another stock in the history, and what these stocks tends to do in the past. What is the stock that has the most similar behavior? So I need a way to compare the one polygonal path to another polygonal path. And one naive way that might work and might not is to say that this polygonal path is very similar to this polygonal path because they have the same vertices in the same point. It also with some gap between them, but if the vertices are very similar to each other, then I'll say maybe it's the same polygonal path. But it has a problem. If I want to find that these two paths are similar, even if each such point is a GPS signal that I measured, and here I was driving a bit slow, traffic was a bit slow, so there are a few more vertices here that don't match any vertices in the blue, but I'll still think about these two curves are very similar, right? Even though there are many more sample points over there. And cleaning sample points will not really help because it doesn't mean that there are 2 points that are very close to each other. I also don't want to say that the red polygonal path with some order is the order matters. I cannot just measure the vertices at all and say that even though the vertices are the same, then that this path is similar to the blue one because it has the same vertices, but the order are the same. I need something that will be sensitive to the ink that I'm leaving as I'm walking along this path, much more than the location of vertices only. And the two algorithms that we are going to see for this problem are the Frechet and the dynamic time warping algorithm, and both of them are using Fifi norm, kind of dog-like worm. And they both start with the following assumption. On one of the curve called P, there is a person that is going to walk along this curve. A person is going to walk along this curve. A dog, Fifi, Golda, is walking along the second curve. Now, both the person and the dog could only move forward from one vertex to the next vertex. There is some time gap that is happening, some steps that are happening in both parts. And I'll assume that the person keeps the dog on the leash at all time. This person keeps the dog on the leash at all time, and the Frechet will ask, hey, is there any way that the person and the dog can both move forward? Some of them might have to move sometimes faster, some will move slower, but can I always make them move forward while the distance between them is never more than 17 yards? Is a leash of length 17 yards enough to connect the person and the dog while the dog move its trip forward and the person move its trips forward? And again, they both have their trips from the beginning to the end while the distance between them is never more than 17? And the answer is that that's depending on who moves when. We said they are all moving together, but if they are moving somehow and try to be close to each other, maybe they need to wait for each other, maybe they need to move a bit faster. But if there is a way, is a lash of length 17 long enough or not? So, to be a bit more formal, I'll assume that somebody gave me the polygonal path P, gave me the polygonal path Q, gave me a target length of the leash, R. R is part of the input and is a number. I want to ask, can I do the whole trip and I need to tell you what the rules of the trip, but can I do the whole trip using a leash of length at most r? And what are the rules of the trip? I'll think about the trip as a sequence of steps where at each the person starts at P1, the dog starts at Q1. The person will end at Pn, the dog must end at Qn, and there are timestamps. It's all synchronized, and at each timestamp, it's possible that either the only person jump from one vertex to the next vertex, or the dog jump from the vertex to the next vertex, or at the same timestamp, they both jump from one vertex to the next vertex. And we'll say that the answer that the algorithm will give is yes, if there is any such schedule of move, wait, move, wait, move, wait. If there is any such schedule for which the distance between them when they are resting is not more than r, the version that I gave you, the target length of the leash. And if yes, then I'll say the distance, the Frechet distance, it's pronounced Frechet, that is silent, after a French mathematician. The Frechet between them is at most 17 if there is a schedule of the dog and the person where they are never more than 17 yards away from each other. Otherwise, we'll say the distance between them is more than 17. No matter how they move, leash of length 17 is not enough. You have to try again, but with a longer leash. And we'll see that once we'll be able to understand exactly what is a Frechet distance, we'll see that this problem lends to an algorithm that is really, really similar to the edit distance and the Frechet and the LCS, and use the same rule, and is extremely useful when we are combining trajectories of cars, we are combining maps, comparing animals, traffic, tons and signatures, lots and lots of applications. Questions, people? Thanks, everybody. Bye.